Hey everybody, it's time once again for my annual winter forecast for the season of winter 2025 into 2026. If you're stumbling across this video on YouTube and you're unfamiliar with me and my work, I'm a television meteorologist in Youngstown, Ohio, and so our focus in this forecast is going to be far eastern Ohio and western Pennsylvania as well, but we'll show you some national maps along the way as we delve into what to expect during meteorological winter primarily. We're focusing on the months of December, January, and February. Our snow forecast is basically first flake to last flake, and as of the recording of this video on the 11th of November, we have seen our first snowflakes at last in my part of the world, but the last snowflakes around here sometimes don't occur until April or even early May, but a lot of times it's at the end of March that we see our last accumulating snows across eastern Ohio and western Pennsylvania. As I like to do when I do these annual winter forecasts, I like to review what happened the previous winter. Last winter, winter of 24 into 25, we did have a mild start to the winter season in the month of December. It was particularly mild right around the holidays. That week between Christmas and New Year's was pretty balmy across this part of the country. The rest of the winter was colder. We had a cold January across most of the region. It was one of our colder Januaries in recent memory, but it did not come with many big snow events, and that was kind of the theme for the back half of winter. A lot of cold air. Not a lot of snow, though. It was another colder than average month in February, but the snow fell well shy of the average. So for the season as a whole, and when I show you statistics like this, these are valid at the Youngstown-Warren Regional Airport, which is in Trumbull County, north of Youngstown, in Vienna, Ohio. That's where we get our official observations for our television market. And at that particular location, I should say, temperatures ended up 1.5 degrees below average for the season as a whole, factoring in daily highs and daily lows. But the snow, it was another pretty pitiful season in the snow department. We've had a few of these in a row now. We average about 66 to 67 inches at the Youngstown-Warren Airport for a season, and we only had 43.5 during last winter's season. That was better than a couple of winters previous to that, but it was still well below the average. So when we look at the daily temperature trace last winter, here was that mild spell right around the holidays, but after that, cold definitely won the battle for much of January and a good chunk of February as well. This winter, I think, will have a different flavor, particularly early on. We'll talk about the forecast in just a moment. But last winter was actually our coldest in 10 years. Look at all the warmth that we've had in the winter seasons since that super El Nino winter back in 2015 into 2016. Now, previous to that winter, we had two pretty harsh winters in the winter of 2013-14 and then 14 into 15. But ever since 15 and 16, warmer than average winters have definitely been the rule, including just an enormous temperature departure from average in the winter of 23 into 24. But last year, 1.5 degrees below average, our coldest in 10 years. In the snow department, the 2020s have not been your decade if you are a snow lover. We've been below the average every season in this decade, and that trend actually started as those warmer winters, I should say, settled in during the back half of last decade. The glory days around here in terms of seasonal snowfall, that was in the mid to late 2000s and early 2010s. A lot of people, of course, reminisce about the winters of the 1970s, all this cold and all this snow, and the snow was up to here, and we had to walk to school, both ways backwards in the snow and things like that. But actually, the snowiest winters on record occurred around here late in the 2000s, early in the 2010s. We had a winter in the early 2010s in which there was over 100 inches worth of snow at the Youngstown-Warren Regional Airport, but recent years it's been a lot different. All right, so how do we make these forecasts? If you follow me or any meteorologist on television and you see us do a routine 7-day forecast, some stations even do 8 or 10-day forecasts. Those forecasts, how we make those, it's a lot different than these seasonal forecasts. Seasonal forecasts, and particularly winter forecasts, we talk more in generalities and trends. Will the winter be warmer than average, colder than average, snowier than average? We can't pinpoint, exact temperatures, 6 weeks from now. We can't say the high on January 5th is going to be 32 or something like that. We can't do that. But we can speak in terms of generalities. And how we generate these forecasts, it's kind of a mix of these three things. We look back at what we call analogs. Past years that we think resemble what's going on in the fall and early winter in the oceans, all of the world's oceans, basically, and in the atmosphere, including very high up in the atmosphere, the stratosphere. So we look at a lot of things to try to match up this winter's ingredients to past winters. We look at those past winters, and then we see what the result was those winters, and we hope to glean some things from that process. We also have some computer models. Now, computer models help us out a lot to make routine forecasts for the next couple of hours, couple of days, 7 days, even a couple of weeks. These seasonal computer models, though, go out much further in time. Now, computer models, as you would expect, become less accurate as you go out in time, but they still can offer some value to a long-range forecaster. Now, some of this comes down to experience and intuition. I've been doing these seasonal forecasts for something like 10 years at this point. I've been a meteorologist professionally for going on 25 years. So I've seen a lot of things. I've hopefully learned a lot of lessons at this point. A lot of forecasts have gone wrong, including last year's. It wasn't great. The initial forecast we put out around this time last year in early November, we expected last winter to be warmer than the average. That did not end up being the case. Now, we did correct the forecast at least somewhat in early December. We put out an update in early December that was distinctly colder than our original forecast, but it wasn't aggressive enough. The cold ended up winning the battle, particularly in the month of January. We did, however, get the snow forecast right last winter. And despite missing on the temperatures, we did call for a below-average season in terms of our snow, and that ended up being the right call. So the main factors for this upcoming winter, highlighting these at the very top, I would say, is the weak La Nina. We'll show you a map of ocean water temperatures coming up. La Nina has to do with waters in the Pacific Ocean. A lot of acronyms, a lot of alphabet soup here, and we're going to try to explain some of these to make this, not so much gibberish for those who aren't meteorologists and maybe have no idea what I'm talking about here, but something called the PDO, which has to do with other Pacific water temperatures, the QBO, which has to do with high altitude stratospheric winds and what that can do to the polar vortex, solar maximum, the sun, very important, of course, to our daily weather, our climate as a whole, and the sun has been very busy over the last few years. We're just coming off what we call a solar maximum, in which the sun has a lot of sunspots. There's a lot of geomagnetic activity. We just had several instances of the northern lights over the last couple of years. Well, how active the sun is can determine things in the atmosphere during the northern hemisphere winter season. We also have lots of warm water in parts of the Atlantic Ocean. That is what we call the positive AMO. And we look at the Indian Ocean as well. The IOD at the very bottom of this list has to do with water temperatures in the Indian Ocean. So here's a look at that map showing the water temperatures compared to average across the world. The reason why we look so closely at water temperatures is because the oceans and the atmosphere, they play in the same sandbox. They can make each other do things. They share a lot of real estate, of course. And when you have warm water in certain places and cold water in certain places, it can make the jet stream buckle in some places. It can make the jet stream do things, and it's all connected. So, for example, that IOD I mentioned, this is the Indian Ocean, of course, right out here. That negative IOD, that means cold water is here, warm water over what we call the maritime continent, basically Australia up through Indonesia, places like that. That dipole, that Indian Ocean dipole, which is in its negative phase right now, it's probably going to be neutral by the time we get into midwinter, but nonetheless, what goes on in the Indian Ocean, like we have going on right now, can have downstream impacts on what the jet stream does over the Pacific and then eventually over North America as well. Here is our La Nina. Of course, your eye is immediately drawn to the middle of the picture here. This is the colder than average stripe of water extending off the coast of South America, heading out into the central part of the Pacific Ocean. The opposite of La Nina, of course, is El Nino. That means the warmer than average waters are winning the battle across this part of the Pacific. Also of great importance and great interest, all this warm water up here extending off the coast of China and Japan and heading out just north of Hawaii. This is surely a sign of climate change because this marine heat wave has really been cranking over the last several years, and it has had a lot of implications for our winter weather in the North American continent and in the eastern U.S. Also, probably climate change related, a lot of the warm water that you see over the Atlantic Ocean. Long-standing warming trends, and what I mean by long-standing, several years in a row, a couple decades in a row even, of persistently warmer than average waters in parts of the Atlantic Ocean. These things are important for the winter season. All right, so, I mentioned we're in a La Nina. It's a weak La Nina. The strength of La Nina or El Nino is important. not just whether you're in one or the other, but how strong is that ENSO phase. ENSO stands for El Nino Southern Oscillation, and it's basically either El Nino or La Nina. When it comes to our weather specifically in our area, our coldest winters on record tend to be El Ninos. They tend to be weak El Ninos. If you have a strong El Nino, it tips the odds in the opposite direction, and some of our warmest winters on record are strong El Ninos. But weak El Ninos, those can be pretty cold. Now, when it comes to our warmest winters on record, you see a lot of strong El Ninos here. One of the warmest on record was a couple of years ago. That was a weak La Nina. You have a few La Ninas on here. There's a little more variety on the warm side of the ledger here. But again, the really, really cold winters tend to be weak El Ninos in our part of the country. Cold weather is favored in that ENSO phase. I mentioned the sunspot cycle. Here's a look at the sun activity over the last 25 years. We're probably just coming off a solar maxima over the last 12 months or so, and while we are in the descending phase of this cycle, this is basically an 11-year cycle, and it's naturally occurring. It goes back millennia, of course, and it's very, very predictable. Right now, we're probably just off that solar maxima, but the solar activity is still high. And that can mean things. The sun can make the high atmosphere do certain things, which can have impacts on the polar vortex up over the North Pole. And when you have a solar maxima, that can sometimes, in concert with other factors, weaken the polar vortex a little bit. And so that may be a factor as we go into the winter season. Another thing we watch, the goings-on in the Indian Ocean out into parts of the Pacific, and something we call the MJO. And again, alphabet soup, right? There's a lot of acronyms in the weather world. MJO is an important one for the winter season. There's a naturally occurring belt of thunderstorms that tends to traverse the equatorial regions from the Indian Ocean into the Pacific, back to South America, back to the Atlantic, and the whole cycle begins again in Africa and out over the Indian Ocean. Well, what does that have to do with our winter weather? All right, so this naturally occurring complex of tropical thunderstorms, as it moves eastward, it can make the jet stream buckle and do things. When this cluster of activity is parked over what we call the maritime continent, basically between Australia and, say, China, when it's parked there, that tends to favor warmer weather in the eastern United States. When that cluster of thunderstorms, that MJO, goes out over the Pacific Ocean, you start to introduce more chances of cold in the eastern United States. Now, when you have a La Nina and the colder water is extending pretty far out into the Pacific Ocean, these thunderstorms don't like cold water. They like warm water. So these thunderstorms tend not to want to go too deep into the Pacific, into that colder zone. But that being said, every La Nina is different, and the strength of La Nina is important here. In a really strong La Nina, these thunderstorms will avoid the Central Pacific like the plague. But in a weak La Nina, particularly a La Nina that's kind of eastern-based, where the coldest waters are in the eastern Pacific, these thunderstorm complexes can meander farther out into the Pacific, and that increases the chances of the jet stream buckling in a way that you can see some cold weather in the eastern U.S. All right, so outside of the oceans, we also look at the atmosphere, and specifically something that's going on high above our heads in the atmosphere. Way up in the stratosphere, it's called, another acronym, another abbreviation here, the QBO, quasi-biennial oscillation. This is a belt of winds high in the stratosphere going around the equator, and this naturally occurring thing reverses course every about year and a half. When it's in a certain phase, it tends to favor warm weather in the eastern U.S. When it's in its opposite phase, it tends to do the opposite. When it's in its westerly direction, that tends to strengthen the polar vortex and keep the vortex kind of locked over the North Pole. A strong polar vortex likes to stay in place over the North Pole. And when the QBO is in its westerly or positive phase, that helps the polar vortex stay pretty strong. We had that last winter. Well, this winter, we're in an easterly or negative phase of the QBO, and that can help to destabilize the polar vortex. The polar vortex can kind of start meandering around a little bit. Instead of sitting and spinning over the North Pole, it can wobble and wiggle, and it can start meandering, and when it does, Arctic air, really cold air, can be dislodged and start coming south into southern latitudes. So this winter, it's actually a pretty strong easterly direction, and we're seeing some evidence already here in mid-November when I'm recording this video that the polar vortex will be quite weak early in the season. and that will increase the chances for some pretty substantial cold weather early in the season, which is a key part of our winter forecast. I mentioned the analogs, the past winters in which we think there's a lot of similarities in the fall heading into the winter season. Here's a list of my top analogs. What you can glean from this is you have a little bit of variety here, but there are not a lot of winters on this list that are particularly snowy. There are a couple of pretty cold ones, and I want to draw your attention specifically to 2000-2001. That winter started very fast. We had a very cold December in 2000. The rest of the winter, the cold backed off some. It was still a colder than average winter in the mean because of what happened in December. You might remember Christmas of 2000 being particularly cold. And there's actually a few years on this list in which we had a really cold December. The winter as a whole didn't end up being all that cold. A winter like 89-90, December of 89, very, very cold. 17 into 18. Again, the winter as a whole was pretty close to average, but December, especially late December that winter, heading towards New Year's, was very, very cold. Even the winter of 2005-2006 had a pretty cold month of December. It snapped in a hurry and went to very warm weather in January compared to the average, but December was pretty cold. So that's a theme in a lot of these analogs, is a cold start to the winter. The rest of the winter was pretty variable, and sometimes the pattern even what we call blowtorched. It got really warm compared to the average at some point during the back half of winter. But 2000-2001, I really think this is a pretty good analog for this upcoming winter season. That was not a particularly snowy winter, but it was a pretty cold winter, especially early on. So looking at those analogs and also looking at long-range modeling, what's going on in the stratosphere and in the world's oceans as of the recording of this video in mid-November, confidence is pretty high that winter is going to get off to a fast start. This is my December forecast, and I think this month has a good chance of being the coldest month overall of the winter season, not only compared to average, but just in the absolutes. We could have a pretty harsh cold stretch. I am not sure what part of the month is particularly favored to be substantially colder than average. It might be the first half of the month, and the cold might ease during the back half of December. But I'm not very confident as of this recording on that idea. But the month as a whole is very likely to go into the record books as a colder than average month of December. As we roll forward into the new year, here's a look at my January forecast. And I wouldn't be surprised if the cold, compared to the average, tries to linger into the new year, into the month of January, particularly if the polar vortex really gets weak, even historically weak for a time early in December. That might have some long-lasting implications, and the cold pattern that we see settle in December might have some staying power into the month of January for our area, and especially points north and west up towards the U.S.-Canada border. Now, February, I think, has the best chance of being a warmer than average month. Now, that comes with a caveat. If the atmosphere is left up to its own devices, it may behave like a typical La Nina, which a typical La Nina tends to end with a warm February. However, if we were to see more shenanigans going on with the polar vortex and things going on high in the stratosphere, which may continue to enhance the cold pattern, this forecast may not end up working out in February. However, if the polar vortex quote-unquote behaves and just stays up over the Arctic for a lot of the back half of winter, February, I think, has a decent chance of being a warmer than average month. So putting it all together, here's what we have for the winter season as a whole. Keep in mind, of course, in a seasonal forecast, not every day is going to be like this. There's going to be variation. But we think locally in eastern Ohio and western Pennsylvania, this is likely to be a near to somewhat colder than average winter season. Will it rival some of the coldest winters on record? No, we don't think that's likely. But it's likely to be colder than some of our recent winters. It may be similar to last winter. The cadence of the cold may be different than last winter. The coldest temperatures last winter, the coldest stretches were in January. This year it might be in December. But the numbers, the statistics might end up being kind of similar to last winter. So one way I can kind of compare things is this kind of very simple plot of comparing this winter to last winter. Colder on this side, warmer on this side. You can see that the temperatures might be pretty similar, but on the on the upper side of the ledger here, that would be a drier than average winter, at least a less snowy than average winter. The bottom side of the graph would be a snowier winter. And we think this year is probably snowier than last winter, even though the temperatures might end up being kind of similar when you factor in all 3 months as a whole. So in terms of our snowfall now, again, if you're a little unfamiliar maybe with the area I'm talking about, this is far eastern Ohio and western PA, and in my television market, we're not in the prime snow belt, but we're just outside of it. We're definitely in a secondary snow belt, and so there tends to be, on a seasonal basis, quite a difference in the average snowfall in a season from north to south. Higher in the north, of course, lower in the south. All of these numbers in our forecast this year are near to slightly below the seasonal average. We get our official observations right about here up in Trumbull County, and the average annual snowfall is about 65 to 67 inches, and you can see I have that area in the 50 to 70 inch range, somewhere in there. Once you get south of Youngstown and south of Route 224, which is a due east-west thoroughfare in the middle of Mahoning County, once you get down towards Columbia and Salem, Lisbon, East Liverpool, in a typical winter, you might see 20 to 30 inches, and I have a lot of those areas in that range. Might you be closer to the 20 than the 30? Yes, in those areas, but still probably more snow than many of our recent winters. But it's not going to be uncommon, I think, to see some 50, 60, 70 inch plus amounts of snow in the northern half of Trumbull County, the northern half of Mercer County. In our viewing area, the snowiest part of our viewing area tends to be northern Mercer County. The lake effect most favors far northeastern Trumbull County and a lot of northern Mercer County. 70 plus inches of snow, certainly not out of the question for the winter season. So, kind of wrapping things up and headlining our winter forecast, we think this is likely to be the snowiest season since 2021-2022. We had about 60 inches that winter at the Youngstown Warren Airport, still below the average, but not far from the average. Since then, our winters have been very lame in the snow department, so this winter is likely to be our snowiest since about 4 years ago, which might still end up being less snowy than average, but at least much more than the last few years. So that's in terms of snow. Now, in terms of the cold, again, we think December is likely to be the coldest month compared to the average, and maybe even overall the coldest month. The back half of winter, not as cold. We're going to go with that forecast for now, but again, keep in mind that is subject to change depending on if we have any meanderings of the polar vortex during the back half of the winter season. So how confident are we in this forecast? I would put our confidence in the overall ingredients going into the forecast pretty high. We know what's going on in the oceans. We know what's going on high in the atmosphere with the QBO. We're in a La Nina. It's a weak La Nina. All those things are pretty high confidence. The temperature forecast, I would put at medium confidence. It's pretty high for December. It's maybe on the lower end later in the winter, and it averages out to be kind of a medium confidence forecast. The snow totals, low confidence, and that's kind of par for the course for a winter forecast. Snow's very fickle, especially when we're talking lake effect. You can have some communities that get walloped with lake effect, and you go a few miles away and there's hardly anything. And so that tends to influence the seasonal snow totals and make the forecast a lower confidence thing. So the overall impacts, I would put medium. I think people are going to spend a fair amount of money on heating this winter. Not as much as some of our harshest winters, but maybe more than recent memory. Last year, of course, was colder, but generally speaking, winters have not been particularly cold in recent years, and we've gotten a little break on our utility bills, relatively speaking, in many of our recent winters. And so this year may be one of the costlier winters to heat your home and business compared to many of our most recent winters. So hope you enjoyed this forecast video. Hope you learned some things from it and kind of how we make these forecasts and why the forecast is what it is. We'll probably update this forecast as we do most years in about 1 month. So look for an update in early December as winter begins to show its hand a little bit. And we probably at that point have a little bit of a better handle on the intensity probably of what is expected to be a cold December, and even we'll have a better handle, I think, at that point on what we can expect heading into the new year in the month of January. So we'll update the forecast as needed coming up in about 1 month in early January. I'm 21 News Chief Meteorologist Eric Wilhelm. Thanks for watching this video, and have a great rest of your day, everyone.